Welcome back. In the previous video, we went over how complex numbers commute for multiplication. We also went over how they commute under addition, and we showed why that was true. So we had started working on the problems in the book. We did problem number 1. I thought we did problem number 2 as well. If I didn't, I'll have to come back to that. But today, while I was on lunch and just at different times today, I had brought a copy of the problems in the book with me to think about. And when I had time, like during lunch, I sat down and started working them out. And so I was able to work on problem number 3, where you show that complex multiplication follows the associative property. If you multiply alpha and beta and then multiply it by lambda, that's the same as beta times lambda and then multiplying that by alpha. So as we did in the other problems, I wrote for alpha, beta, and gamma. I wrote them as A plus BI, C plus DI, and E plus FI. Sorry, I had this paper with me all day. So you replace the alpha and the beta by A plus BI and C plus DI, and the lambda by E plus FI. So the way I did this is the left-hand side I did here. But the right-hand side, I wrote out over here. And the trick to doing this was I did the multiplication going down for the left-hand side and wrote it in the form of a complex number, A plus BI. And I did the same thing for the right-hand side. I wrote that in the form A plus BI. And what I did was I then looked at both sides to see how I could get them equal. And since I'm dealing with real numbers being added and subtracted, all the regular rules for associativity and commutativity work. So I could reorder these letters to match the letters over here. So I just need to justify the steps for you up here. So this to here was complex multiplication, the regular way, and it's written in the form A plus BI. Then I used the distributive property. Oh no, I used complex multiplication here because this is A plus BI and this is in the form A plus BI. So the regular rules for multiplication work. So I wrote that out, the multiplication. And then these numbers here are real numbers. So I was able to use the distributive property for real numbers and wrote them out. And similarly, in front of the I, these are real numbers. So you can use the distributive property and write them out. So going down on the right-hand side, it's the same argument. Complex multiplication here, write it in the form A plus BI. Then did complex multiplication here. And then the real numbers, I was able to use the distributive property. And the same thing for the real numbers in front of the I. And so just to give you an example, ACE on the left is right here. Minus ADF is there. Minus BDE is here. And you could write these as plus negative. And you know that under addition, real numbers is commutative. You know, plus negative BDE plus negative BCF. And then you can rewrite it as a minus when you're done. Over here, you see EBC, and there is BCE. Well, because multiplication for real numbers is commutative, I could write an associative. I could rewrite EBC as BCE or BDF as FBD. So that's how you get between these two sides. So you go straight down here and then go up this way to get to the other side. So you could reverse these steps for the justifications. It's easier than unraveling the multiplications was to do the multiplication on this side instead of figure out how to rewrite this as a complex number and rewrite it as the right multiplication over here. So that was the trick for figuring this out. And then you would just follow it one way. If you have any questions, so that's problem number 3, showing the associative property under multiplication for complex numbers. Now, I also did lambda times alpha plus beta equals lambda alpha plus lambda beta. The reason I had to write stuff in the previous problem in its complex number form was because we didn't have the distributive property for complex numbers yet. So rather than using the distributive property, I had to use the multiplication property. Okay, so now I use the same lettering. Lambda, I use A plus BI. Slightly different. I wrote A plus BI for the lambda, C plus DI for the alpha, and E plus FI for the beta. I did that on both sides, and I used the same method of working down on each side until I got them to match. And then you can just go down this way and reverse these steps to get to this side. Okay, so that's a trick, is if you get stuck at some point on one side, you work on the other side and try and get the two to match. All right, so I rewrote alpha plus beta. Addition, you add the real and imaginary parts. That's this here. And so you have a complex number where the real part is C plus E and the imaginary part is D plus F. So you have the product of two complex numbers. So let me underline that. So here, this is in the form of the real and the imaginary part. I've been using that over and over. So I'm not writing that every time. I just wrote that this time to help you out a little bit. You can go back in the video. I use this fact in other places where I didn't write it like that. I just said it for you. Okay, so when you use complex multiplication, you'll do A times C plus E, for example. Well, that's multiplication of real numbers, and then you can distribute the A to the C and the A to the E. Also, the BI times d plus fi for the complex multiplication. So it's I times I is like I squared, which is -1. And b times d plus f is bd and bf. The -1 distributed to both of them. So I just gathered together the real part and the imaginary part using the rules of for real numbers to do that. And it's in the form a plus bi. On the other side, I wrote out the same, the lambda a plus bi, alpha c plus di. And I used multiplication for complex numbers for each of these two items. That's how I got this. And then I used addition for complex numbers to combine them together. Like the AC minus BD combines with the AE minus BF. Because to add two complex numbers, you add the real parts and the imaginary parts. And at that point, you're combining real numbers. And so the real number properties hold. Now, to get both these sides equal, I hope they're equal. Let's see, AC, yeah, you see the AC, AE plus AE minus BD and minus BF, for example. And in the parentheses, remember, like for real numbers, the commutative and properties under multiplication and addition hold, and associativity, you don't have to worry about where the parentheses are. So you just follow on the left hand as I justified the steps, and then go up on the right hand side, and you show that the distributive property holds for complex numbers. So that means we now have for sure commutativity and the associative property and the distributive property. And so now we're able to use those whenever we want, which is one reason for trying to do all the problems in a book. Because sometimes results in these books are actually useful for proving things and doing things later on. Okay, so I believe we've done problems 1, 2, 3, and 4 so far. And Lord willing, we'll continue going over this some more tomorrow. Thank you for watching.